Today we're talking about compound rates. We've seen examples before where we had to take the size of the patient and multiply it with the order to find the dose. For example, if we had a problem that said the patient weighs 100 kilograms and has an order to receive 2 micrograms per kilogram, we would take the 100 kilograms and multiply it with the 2 micrograms per kilogram. The kilograms would cancel out and we'd find that the dose is 200 micrograms. If we look at an example with the compound rate, we still start with the size of the patient and multiply it with the order, but this time we'll end with the dosage rate. For example, if the patient weighs 100 kilogram and has an order to receive 2 micrograms per kilogram per minute, we have our compound rate. We still start with the size of the patient, 100 kilograms. But with our compound rate, 2 micrograms stays up in the numerator. That second part of the unit rate, the kilograms per minute, goes in the denominator. And it'll always be that way, where the first part of the rate stays by itself and the second 2 units always go together. Our kilograms once again cancel out, and we're left with 200 micrograms per minute. If we look at another example, it says the patient weighs 80 kilograms and must receive dopamine hydrochloride at the rate of 3 micrograms per kilogram per minute. How long will it take the patient to receive 50 micrograms of the drug? Because they're asking how long, we know that we want our answer to be time. So this time when I look at that compound rate, the 3 micrograms per kilogram per minute, instead of writing it as 3 micrograms over 1 kilogram per minute, I'm going to flip that unit fraction in my dimensional analysis. So I'll have 1 kilogram per minute over the 3 micrograms. I'm doing this because I want to end in time, so I want to start with that time, that minutes, up in the numerator. Now I'm going to use dimensional analysis to cancel out the kilograms and the micrograms. They told me that the patient weighs 80 kilograms, so I'll put that 80 kilograms in the denominator to cancel out the kilograms. That's not a part of a rate, so the 1 goes up in the numerator. Now I need to get rid of the micrograms. They tell us that the patient is receiving 50 milligrams of the drug. So first I'm going to go from micrograms to milligrams. I know there's 1,000 micrograms in 1 milligram. Then I can multiply by the 50 milligrams that the patient is receiving. The micrograms cancel out and the milligrams cancel out. I can put that milligram over 1 to remind me that it's not a part of a rate. Now usually when we're asking how long it's going to take a patient to receive a drug, we answer in hours or hours and minutes. So I'm also going to get rid of those minutes and get them to hours. I know there's 60 minutes in every 1 hour. When I multiply straight across, I'll end up with 50,000 over 14,400. When I divide, that gives me 3.472 repeating hours. Now we know we won't answer as that. So the 3 is going to remain the hours portion. And I'm going to take this decimal part of the answer and find the minutes. So I'll take that 0.472 repeating hours and use my dimensional analysis to convert it to minutes. When I do that multiplication, I find that I have 28.3 repeating minutes. We know we don't use that decimal part, so when I round, I know that I'll say that it's about 28 minutes. So for our final answer, the patient is going to take 3 hours and 28 minutes to receive 50 milligrams of this drug. Let's look at another example. The prescriber ordered 250 milliliters of 5% dextrose in water solution with 60 milligrams of a drug, 0.006 milligrams per kilogram per minute, intravenous piggyback daily. The patient weighs 70 kilograms and the drop factor is 20 drops per milliliter. Calculate the flow rate for this drug in drops per minute. So this time I do want to end in drops per minute. So I'm going to start with that compound rate the way it's given to me, that 0.006 milligrams over 1 kilogram per minute, because I already have minutes in the denominator. Now I'm going to use the problem to get rid of the milligrams and the kilograms. They tell me that the patient weighs 75 kilograms, so I'll start there. Now I need to get from milligrams to drops. First, I'm going to use the information from the order, that there was 250 milliliters of the solution and that there were 60 milligrams of the drug. So I'll put that 60 milligrams in the denominator to cancel out, and I'll put 250 milliliters up in the numerator. So now I have volume over time, but instead of milliliters, I need drops. So I'll use that drop factor. In 1 milliliter, there are 20 drops. So everything will cancel out except my drops per minute. When I multiply straight across, that gives me 37.5 drops per minute after I also divide. Now we know we can't have a part of a drop, so I'm going to round to the nearest whole. That gives me 38 drops per minute for my final answer.